Hi, hello, welcome back to MATLAB learning sessions. Today we are learning about MATLAB multiplication. Okay, in MATLAB actually there are two types of MATLAB multiplication usually we use. The first type is element-wise MATLAB multiplication, or second wise is matrix multiplication. We will see how those two will perform in the MATLAB now. Okay, so these are two types. First method is element wise multiplication and second method is normal matrix multiplication. Okay, I will come to this explanation to after 2 3 minutes. So now we go to see how matrix multiplication generally is possible. Okay, so here you see scalar multiplication. Generally we have scalar multiplication and matrix addition. Just I put this slide to get some understand by the to remind some conditions that have for the MATLAB multiplication. Mm, like matrix multiplication, because why it is important here. Matrix means in MATLAB the every data will store like a matrix. Okay, so in the number of number of rows, number of columns, in that way it will store the data. So MATLAB itself a matrix calculations it will do. So it is essential and important to understand the matrix addition, matrix multiplication, the rules of that. Everything is important for to be good MATLAB performer for the coding and anything, to understand the MATLAB easily and correctly. Okay, scalar multiplication, you see there it is visible here, n into uh, a matrix, that is number of rows by number of columns, 2 by 3 matrix. Okay, so a scalar multiplication, how it is did, how it is done here: n into a, na, n into b, nb, n into c, nc, like n into d, n into e, n into f. Okay, it is like this. The scalar multiplication it is called. Okay, matrix addition. Matrix addition is say a plus g, b plus h, a plus g, b plus h. But it's not like a G, B, H, A, G plus B, G, H. It's not like that. Okay. So matrix addition is element to element. So first element to first element, second element to second element addition only is the right process of MATLAB addition. Sorry, matrix addition. So matrix multiplication, how it is? So number of elements in the first row, number of elements in the first row of first element, that should be equal to number of columns. Here three elements are there in the first row. 1 2 3, this is first row. 3, so 3 columns should be there. 1 2 3, 1 2 3. So simply you can say number of columns in matrix A equal to number of rows in matrix B, then only multiplication is possible. Then only multiplication is possible. So if this condition is not there, if this condition is like matrix A number of columns equal to matrix B number of rows, if this is not there, if this condition is not true, means the matrix multiplication is not possible. Okay, these are the conditions like in multiplication of matrix. Okay, just some example I shown here to get understand what I am going to explain in this tutorial. Okay, now I will go to explain about this too. So here yeah, already we've seen that element wise multiplication and matrix wise multiplication. Element wise multiplication is nothing but uh, one element to other element, like addition is happened, right? Addition is happening, a plus g, b plus h, like that. So element wise multiplication means element same position element and same position element will get multiplied. Okay, a into g, again b into h, again c into I, again d into j, c into k, f into l. So such a manner of multiplication is element wise multiplication, that's called element wise multiplication. And this is matrix multiplication that we know already. Even we are doing numerical sums in the matrix textbooks. So the same multiplication is matrix multiplication. That is what we are seeing here. Okay, so there are two built-in functions for the multiplication in the MATLAB. One is times and other one is m times. Times indicate that element-wise multiplication. M times indicates that matrix multiplication. So using these two built-in functions, we can write by using matrix A and matrix B and matrix A and matrix B times A comma B means that is element wise multiplication, either this function or this function. Once you define matrix A and B, following by that, if you write this syntax or this code, both will give same result. And yeah, these also same means, yeah, matrix multiplication will be done based on this syntax using or this code, both will give same results. Okay, so two types we have. Either way you can use, either by using built-in function means this syntaxes, built-in syntaxes, or by using this type of code. Yeah, by using operator, I can say by using operator, because this part we are calling as a operator, multiplication operator. Okay, yeah, so here I put few examples like matrix or arrays. So here another word I am introducing like arrays. What is array? Array is a specified elements arranged in a specified manner. Okay, that is in number of either row or column. uh, uh, um, one group of elements is arranged in a manner that is called, generally we call it as array. So here two types of arrays are there. Then array may be a matrix or a vector. Well, yeah, it is again theoretical textbook learning things. So please have that knowledge while uh, coming and learning about MATLAB. That is basics that is need here for the better understanding. So I am taking here, yeah, I will take a single column array uh, uh, and rows. Just I will explain about these two. So first I am taking one 3 by 3 matrix x and y, 3 by 3 matrix x and y. So this is element wise multiplication, means see the symbol, the operator I used here is uh, dot in dot following by star, x dot star y, that means, or the same thing you can it will perform like times a comma b. Okay, we will see these two, and after that we will see this and we will see this. So just I am taking this matrix to the MATLAB dashboard. Okay, this is MATLAB command window, we know that. So I am copying my matrix x, so x is displayed here, and the same I will take my matrix y, my matrix y. So x and y I defined, x and y I defined. Now what I am going to do, I am going to do element wise multiplication. How element wise multiplication it will done? Element wise multiplication, I am just a variable name we can give anything in a meaningful manner. Okay, so that's why EWM I given element wise matrix multiplication. Okay, element wise multiplication, x dot star and y. It should be y, capital Y, because matrix is a MATLAB is a case sensitive. Okay, we should not use small x and y. So here we defined capital X capital Y, so definitely we should use capital only here. So enter. So it is given element wise multiplication. So we will see the understanding of element wise multiplication. So this x and y, 1 into 0 0, the result 1 into 0 0, and 2 into 9 18. So here 18, and minus 2 minus 3 into 1 minus 3. Okay, and 2 into 2 4, minus 1 into 4 minus 4, 7 into minus 1 minus 7, minus 4 into 0 0, 1 into minus 1 minus 1, 2 into 0 0. So first element we call it 1 1 element into 1 1 element of this matrix. So both into the result is here. And 1 2 element of this matrix into 1 2 element of this matrix. Okay, 1 3 element of this matrix into 1 3 element of this matrix. Here 2 1 element of this matrix, 2 1 element of this matrix. So I am calling here 1 1 1 2 1 3, right? What is that? 1 1 position of this number, 1 2 position. 1 2 position means 1 is the first row, 2 means second column, 1 2 element, 1 3 element, 1 4, here 1 4 element is not there because 1 4 means first row, 1 4 means fourth column is not there. So here possible, this is 1 1 element, this is 1 2 element, this is 1 3 element. Okay, what is this one? This one, third row, third element, 3 3 element. Okay, x of 3 3. For example, you see this x, okay, 3, x 3 comma 3. Will you display? Check. 2. Yes, x 3 comma 3 is this one, 2 element. And you can check x 1 1 element. I called this one, right? Okay, you can see x 1 comma 1 1. So the position of each element, we can call it first row first element, first row second element, first row third element. That is only I am saying 1 1 1 2 1 3. In that way I am calling these elements. So yeah, this is also one on the skill point to learn while dealing with MATLAB codings for anything. Yeah, so this is one thing. This is element wise multiplication. Element wise multiplication means it is same position element will get multiplied by same position element into the in the second matrix. Okay, so what is matrix multiplication? So element wise multiplication is, we learned it. So what is matrix multiplication? I am just taking this, so I delete this dot. So matrix multiplication only, right? So matrix multiplication, I can take just matrix multiplication. Okay, x and y. Yeah, it is x and y means this one. So how this is x and y? Yeah, we know, right? So these elements will get multiplied by these elements and get added. 1 into 0 0 plus 2 into 2 4 plus minus 3 into 0 0. So finally how much it will come? This is 0, this is 0, this will be 4. Yes, 4. That will be 4. And if you see look at any number. Okay, I will calculate for this 7. I will calculate for this 7 between these two. 7 7 this position, right? 2 2 position, 2 second row second element means 2 2 position, 2 2 position. Okay, for this one I need to do for this one, no? Yes, for this position, this by this, for this position 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 this by this. In the same way, for this position, which one I need to take? Yes, second this second row, this second row into second row into second. So 2 into 9 18, 2 into 9 18 plus minus 1 into 4 minus 4, 18 minus 4 14, 14. Okay, plus 14 into plus 7 into minus 1 minus 7, 14 minus 7 7, the result will be 7. It will be 7 only. So normal matrix multiplication will perform by x star y, x multiplication operator y. Okay, and element wise multiplication will happen like this as we seen. Okay, yes. And what we have other thing also, check, yeah, times we will see. based on inbuilt functions times and m times. How that will look up times. So I am going to perform same this element wise by using times x comma y. Okay, we'll copy this same, and I am going to write by I can go built-in function. Okay, built-in function. I need to write times x, give x comma y, and write. So see, this is built-in function by using times. So is that 0 18 minus 3 4 minus 4 minus 7 1, is that same with element wise multiplication? Yes. Is this both are same? 0 4 0 18 minus 4 minus 1 minus 4 minus 1 minus 3 minus 7 0. Yes, minus 3. So by using this operator, element wise operation operator, or by using built-in function, we will get the same result. As I said, we will get the same result. Where we cite, where we see cite in the first slide. In the first slide, by using this function or by using this function, we will get same result. And here also same, by using this or by using this, we will get same result. So I will show this one also. So yeah, let's write from here, copy paste. It will be, sorry, I am doing copy paste the syntaxes. Okay, it is matrix multiplication with built-in functions. That is why I kept b. So m times x comma y. Yes. So see, this is matrix multiplication by using multiplication operator, and this is by using built-in function m times. Okay. So see, both results are same. Yeah, that's what I am saying. By using either built-in function or by using either regular function, by using which regular functions are generally use operator, built-in function generally use the built-in functions. The purpose of function is defined within the MATLAB. So these are the built-in functions and these are the operator functions. Okay, these are yeah, two important thing. And we'll see the next what it is. Check why. So yeah, here there is the above will not work for matrix multiplication. Why we will check. So first of all, uh, you know this, what I am writing here, observe it. Y equal to 2 is to 5. 2 is to 5 I given. 2 is to 5, what is the mean of this means? So MATLAB what it will do, 2 to 5, 2 to 5, it will display 2 to 5 with a gap of 1, with the distance of 1. 2 to 3 distance is 1, 3 to 4 distance is 1, 4 to 5 distance is 1. So 2 to 5 including 2 and 5, it will display the numbers, how many integers without floating number. uh, Floating number means nothing but decimal numbers. If the without decimal numbers, it will show all the integers here. Okay, so this is why. Simply I can say this is one type of array, numbers array. It is one type of array, the serial number of array from 2 to 5. Yeah, or else we can take it as a vector, one row vector. Okay, yeah, that is also possible. You can call it as a row vector. And the other thing, what we have here, row vector, and it has transpose. That I will give transpose in MATLAB directly. Okay, it is one transpose. Okay, 1 is to 2 transpose. If you tell it, so transpose is yeah, generally first you see what is the meaning of these two. So if row r is equal to 1 is to 2, 1 comma 2 it is given. This is a row elements, this is a row elements. So if you give this transpose, what it will become, row will become as a column. Okay, this is 1 and 2, it is in column, it is in row. I can say this is row vector, column vector, this is a row vector. Okay, I can say this is uh, what we will see number of rows into columns, right? Okay, then this is 2 by 1 matrix, this is 1 by 2 matrix. I can say this is like a uh, row matrix, this is a column matrix. Okay, yeah, that is the difference between these two if you use transpose for any series of numbers. So for what I have to take here, y, this y, and transposed or this y and transpose. So as I written here, what it will come, the second point will come, I need to overwrite this. Why we the overwrite point I told in the first class actually. So what it will become if I am overwriting is, so r I written here, this is the value stored in the MATLAB for r variable. Again I written this one. So what will happen here, this r value as a column vector will overwrite as a row vector. Again I am using with the same type of variable. Okay, so no more. If for example, if I check now what is the value of r, so whether it will show column vector or either it will show row vector. Let's check. It will show row vector. This is also there r equal to, but it's not showing. This is one showing, means the r value is overwritten by row vector. Not no more in this code. No more r is a column. It is always perform as a row only. Okay, because we written second time. Okay, we defined second time, we confirmed this r variable value as a row column 1 comma 2, row matrix 1 comma 2. So that's why r is equal to show as a row vector. So that's why for my coding to check, I need with the transpose column 1. So that's why I'm giving this. So why we are doing this means just to check matrix multiplication rule. So this y 2 is to 5, how many elements it has? 4 elements it has. And this one, how many elements it has? 2 elements it has. For example, as we know, for matrix multiplication, this should be like how many elements in the first, how many elements in the row in a matrix 1, the same number of columns should be there in the matrix number 2. In the second matrix, same number of columns should be there as how many elements in the rows, in the row in the first matrix. So here number of elements in the row is 4, number of elements in the column is 2. These are not possible, not compatible to do multiplication. Okay, what will happen if I do multiplication? Let's check this. Okay, yeah, I am copying same, do it. Element wise multiplication is done. Then what will, then matrix multiplication, it's not happening. Matrix multiplication is not possible because matrix multiplication, definitely there are 4 elements in the y, there are 4 elements in the y. So definitely here 4 elements in the first row. So definitely here 4 columns should be there, then only it is possible for the matrix multiplication. But element wise multiplication, it is done. It is done means what, how it was done? It is done means, see, 2 2 is here, 2 into 1 2, 2 into 2 4, 2 4, and next another element will come 3, 3 into 1, 3 into 2, 3 6, 3 6, 4 same, 4 8, 5 means 5 10. Yeah, so yeah, you can for the easy, mhm, we can see 2 3 4 5, right? Yeah, so this element into this element and this element into this element, that both are taken into, yeah. And also in multiplication rule, the size will change, right? When both are not equal, size will change. Yeah, size here it is changed like 2 rows 4 columns, 2 by 4 matrix. Okay, so if these are what is the meaning here? It is happening, element wise multiplication is happening, but matrix multiplication is not possible. Now vectors, a1 vector and b1 vector. Okay, I am taking this a1 vector, a1 vector, this is a vector, some elements, number of elements are there, and I am taking b1 vector, b1 vector, a1 vector with equal elements, with equal elements, how many elements this has and same number of elements it has. Okay, I am vector element wise, yeah, first doing that vector element wise multiplication, vector element wise multiplication, element wise multiplication, 1 0 0 2 9 18 3 minus 1 minus 3 2 2 4 minus 1 into 4 minus 4 7 into minus 1 minus 7 minus 4 into 0 0 1 into minus 1 minus 1 2 into 0 0. So this is element wise, element into element is the element wise multiplication. That is what we seen in this example, or the same result will come from this inbuilt syntax also, element wise multiplication. You see, element wise these two are same, yeah, either you do in this way or either you do in this way, the result will come same. Okay, let's see, if you do a1 into b1, what it will show. It won't, because the number of elements in the row of a first element are like 6 9 elements are there, but here only one one row is there here. So number of, here I can see 1 2 3 4 5 6 7 8 9. If you see in a column wise, 9 columns are there, 1 2 3 9 columns are there. Here number of rows are only one. So the rule is number of columns, if you see in this way, number of columns in matrix A, or else in the first matrix equal to number of rows in the second matrix, then only multiplication is possible. So that is not uh, that is not true for these two matrices. That's why normal matrix multiplication is not possible, but element wise multiplication is possible. So what we are learning here, element wise matrix multiplication is not dependent on the size of matrix, it will perform for anything, but matrix multiplication definitely need to satisfy the conditions, right? Yes, and now we'll see tables, like, yeah, as I already said, tables, we can create the tables of addition subtraction, maybe per, yeah, extensive extensional performance we need if in the, like in data science level, if you want to create tables and manipulate them and do them in such a way, 2003 a version onwards it is supported. Before the earlier older version than that will not support for that, for these operations. But we can see here, just to create, oh, I am creating a table, I am creating a table by using a code. Okay, okay, a table I created, a table, table A, this is 3 by 2, 3 rows, 3 rows, 2 columns, 2 columns, 3 by 2 table I created. I am going to create one more 3 by 2 table, one more 3 by 2 table. Okay, two tables I created, AT and BT. So now what I'm going to do, see, here AD for example, this is element wise multiplication, right? Yes, element wise multiplication for tables. is not supported for operation for chip. Yeah, so that is what I'm saying. For tables we can create, but doing these things, this version I'm using 2022b. So in this version it is not possible. It is possible from 2023 a version onwards. Okay, so only element wise matrix multiplication is introduced in 23 version. Multiplication is not supports. Multiplication is not support for tables. Okay, but normally we have seen just now all the things, but for the table creation, like which have the text also, for this one directly multiplication is not possible in the present one. So rules of matrix operation, what is element wise multiplication, both matrices must be the same size or compatible. Yeah, anyway, either it is compatible or same size, it will be operate. And matrix multiplication of any two matrices, the number of columns in matrix X equal to the must be same to the number of rows in the matrix Y. That means X is the first matrix, Y is the second matrix. The number of columns in the X matrix should be equal to number of rows in the second matrix. Then only matrix multiplication is possible. Okay. Yeah, if you see some skill point, smart, uh, how to pick a single element or a row or a column from a matrix. Okay, yeah, this I can say. I will first delete all these things by using command and clear command history. And this one, what is we write to close everything? Clear, no, oh, I am using capital. Clear all, close all, CLC, so everything will go. Okay, fine. So I will just define one matrix 1 2 3 and 6 7 8 and 9 5 7 and 5 0. Yes, okay. Yeah, this is matrix here. 1 2 3. This is first row, this is second row, this is third row. Each row is separated by colon. Okay, so for example, what should I do? mm, Matrix A and 1 comma colon, what I am doing? Yeah, just now we have seen, right? If I do 1 comma 1, what element will become? First element will come. This is 1 come first column, sorry, first column. Okay, so I am writing now other one 3 3. So that means um, first row, third column element. Okay, first row, third column element. First row, third column element 3. This is 3. Okay, let's check whether this is correct. What is the 3? 3 came here. Okay, 3 came. At the same, I will write another one. I want to display these 3 also. That is in third row, second column. Okay, I am writing this third row, second column. Okay, third row, second column element 3. Okay, if I want to this one, I can give third and third. Hey, sorry. Yeah, it's going automatically. 3 and 3, 3 and 3 means 0. That means 3 and 3 position is this one. Okay, we can pick in this way any element that is there in the matrix by defining like this, that position. This is indicates matrix A. If it is here, for example, 10 matrix are there, you given 10 different names, then take that matrix name here and write it. You will get exactly that. So for example, I want to write the complete row of this first row. 1 2 3 I want to write. What I do, I need to write a 1 comma east, you give and put it. So first row is came. So to write rows, we need to write numbers here, first, second, third. This is 3 rows only there, right? So we can write. So if I give 2, it is come second row, and if I give 3, it will show third row. Okay, 1 2 3 6 7 8 9 3 0, 1 2 3 6 7 8 9 3 0. So each row to write the rows like this. And what yeah, I hope you understood now what I need to write. If I want first column, give 1 here, just the reverse. First column 169, 169, first column is displayed. And if you want second column, put here 2, second column. If you want third column, put here 3, third column. So column can be in the second position, row can be in the first position. Rows can write in this way, column can write in this way, and each and every element can be defined in this way. We can fetch from this in this way. Okay, I hope this is good learning and helpful. And we'll see some examples x and y. Yeah, I hope we written this already, and you can do this within in your online browser or in your MATLAB. Okay, you can get that examples of this. Yeah, just I want to show this example, the first two examples, these two examples, because there are something to learn. There are something to learn from this. And I'm going to clear this. Clear all, close all CLC. Okay, fine. So what I'm doing, I am defined one element. So write this 4 element wise multiplication into x. Yeah, element wise multiplication into x. 4 into this element, 4 into this element, 4 into this element individually, and 4 into this, 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 4 individually multiplied element wise. Here only 1 is to 1 matrix, 1 row 1 column matrix, 1 comma 1 size. Okay, but this is 3 by 3 size. This is 3 by 3, 3 rows by 3 columns. Okay, so it is possible. And the same thing, check for matrix multiplication. Yeah, see, both are same, both are same. Yes, for this, a scalar number is multiplying to matrix. A number is multiplying to matrix, we call it as a scalar multiplication. Where we saw scalar multiplication? Scalar multiplication we saw here. Scalar n into multiplication, any size of matrix. Okay, that number multiplying to any matrix. Okay, it's nothing with the size of matrix. A scalar, while a single number is multiplying, whether it is element wise, either it is matrix wise, it will give the same result. It will give the same results. It won't depend on any type of other things. Scalar means it's directly will go and get multiplied by each and every element. That will give the same elements, same results, whether element wise multiplication and matrix wise multiplication. Yeah, that is the different, only the different. in this example, and rest all we saw already. Okay, you practice these two from your end. Yes, thank you. I hope this is helpful. Thank you for